Welcome to my YouTube channel. I am Tejaswini.M studying in Sri Venkateshwara College of Engineering. Today we are going to discuss about the how does the loading effect impact the input impedance of circuit. Introduction to loading effect. The loading effect occurs when a circuit's output interacts with a connected load. This interaction can alter the behavior of circuit, particularly its input impedance. Understanding the loading effect is essential for designing efficient electronic circuits. What is input impedance? Input impedance is a measure of resistance a circuit present to an input signal. It is circular for determining how much of input signal is transferred into the circuit. High input impedance is often describable to minimize signal loss and distortion. Causes of loading effect. The loading effect typically arises from the finite output impedance of the source circuit. When connected to a load, the output impedance interacts with the load impedance. This interaction can lead to voltage drops and alter circuit performance. Impact on input impedance. Loading can significantly reduce the input impedance of the circuit. A lower input impedance can lead to higher current drawn from the source circuit. This change can affect the overall signal integrity and performance of the circuit. Voltage divider rule. The loading effect can be analyzed using the voltage divider rule. When a load is connected, the total impedance seen by the source changes. This results is a different voltage being supplied to the input of the receiving circuit. Partial examples in audio circuits connected a load impedance, load can significantly affect the sound quality. In measurement system, loading effect can readings by altering expecting impedance. Engineers often use buffer amplifier to mitigate the loading effect is critical application. Give equation input voltage on the CE amplifier circuit AC equivalent effect of input impedance. Introduction to CE amplifier. The common emitter amplifier is a widely used configuration in electronics. It provides significant voltage gain and its effect often used in signal amplification applications. Understanding its operation is circular for designing effective electronic circuit. Basic CE amplifier circuit. The basic CE amplifier circuit consists of a bipolar junction transfer BJT. It includes resistor for biasing and coupling as ensuring proper operation. The circuit typically shows the input at the base, output at the collector and emitter grounded. Input voltage equation. The input voltage for the CE amplifier can be expressed as Vin equals Vb minus Ve. Vb is the base voltage while Ve is the emitter voltage, which is often at ground partially. Potential. This equation is essential for analyzing the amplifier's input characteristics. AC equivalent circuit. The AC equivalent circuit simplifies the analysis of the amplifier's frequency response. In this model, capacitor block DC and are treated as short circuits. This allows for a clearly understanding of how the input signal is amplified. Key, Key parameters of CE amplifier. The key parameters includes input resistance, output resistance and voltage gain. The voltage gain can be represented as AV equals to V out by V in, high, highlighting the amplifier's performance. Understanding these parameters is essential for designing an effective amplifier circuit. Effect of input impedance. Input impedance affects how the amplifier interacts with the presenting stages. A high input impedance minimizes loading effect on the source circuit. This ensures that the input signal is not significantly attenuated before amplification. Calculating input impedance. The input impedance of a CE amplifier can be approximate as Rin is equals to beta. Hence, beta is the transistor's current gain and Re is the intrinsic emitter resistance. Load effects. Load effects occurs when input impedance of amplifier is not significantly higher than the source impedance. These can lead to a reduction in the input voltage affecting overall performance. Understanding loading is important for ensuring optimal amplifier design. Conclusion. The loading effect plays a critical role in shaping the input impedance of circuit. Understanding and managing these effects is vital for effective circuit design. Engineers must consider loading effect to ensure optimal circuit performance. Summary of this topic is the common emitter amplifier is a versatile and essential circuit in electronics. Understanding the input voltage equation and the effects of input impedance is vital for effective design. By optimizing these parameters, one can achieve sup- superior performance in amplification.